Bismillahirrahmanirrahim, my dear second year class students. Now we move on to the glands which are associated with the GIT. Now next is the gallbladder, and you all know that is the gallbladder is the structure which is related with the secretion and concentration of bile coming from the liver. Pear-shaped structure meant for storage and concentration of bile. This is an important function because the bile is continuously produced by the liver, and first it is stored and concentrated in the gallbladder, and at the time of need it is poured into the duodenum for characteristic purpose of the emulsification of lipid. It is lined by mucous membrane covered by simple columnar epithelium with apical microvilli. ये बात आप याद रखें कि इसकी epithelium is lined by the gallbladder is columnar epithelium, simple columnar epithelium with apical microvilli. So microvilli are the projection of the surface epithelium. Lamina propria underlying the epithelium is made up of connective tissue. The smooth muscle layer is also present, which show contraction during the evacuation, and when it is released it becomes balloon. So smooth muscle are meant for squeezing the gallbladder to pour their secretion into the cystic duct. Serosa plus adventitia is both present in the gallbladder because at some places it is intraperitoneal and in some places it is extraperitoneal. When there is the peritoneal covering, it is serosa, that is simple squamous epithelium with little bit of connective tissue. Adventitia is the connective tissue layer. So you will have to differentiate between these two, adventitia and serosa. Serosa is the peritoneal lining. Mucosa is folded itself and close to the suction duct. It's elongate to form gland-like structure that secrete mucus. So ये भी याद रखें कि ग्लैंड इसके अंदर नहीं होते, लेकिन मिकोजा जो है वो सिस्टिक डक्ट के करीब जो है वो फोल्ड हो जाता है, एंड ए बिट अमाउंट ऑफ म्यूकस इज secreted within the gallbladder. सो इन सच इसके अंदर ग्लैंड नहीं है, लेकिन जो म्यूकोजा है वो फोल्ड होकर इलांगेट हो जाता है टू फॉर्म ए secreting gland which secrete mucus. Now this is the histological cut section of the gallbladder. Look at the picture. The adventitia is outermost. Next is the muscle layer, quite evident in this. These are the smooth muscle layer. It is meant for the squeezing purpose of the gallbladder to pour the secretion within the cystic duct. This is the lumen, and the epithelium is the simple columnar epithelium with apical microvilli. The lamina propria is beneath the surface epithelium. These submucosa, this is the mucosa, and submucosa is little bit amount of connective tissue present beneath the mucosa. The muscle layer is also present, which is thin. So this is the cut section which is visible in the light microscopy. Now we move on to the next very important gland, that is the pancreas. Now you all know the pancreas is the important gland which is situated in the retroperitoneal space posterior to the stomach and above the transverse colon. It is both exocrine and endocrine. So this pancreas is meant for the secretion of very important hormone, that is the insulin, glucagon and somatostatin. This is the diagrammatic presentation. Of the anatomical basis of the pancreas. Look at the picture. So this is the duodenum. So it is the cap of the duodenum which enclose the head and neck of the pancreas. This is the head, this is neck and body and tail, this is spleen, and these are the splenic vessel, splenic artery. And look at the picture. The pancreatic ducts are visible, bile ducts are visible over here. So this is the diagrammatic presentation. You see splenic artery, then the bile duct, common bile duct, which pour the secretion within the second part of duodenum, pancreatic duct, acinar cells, section, hypothetical diagram. This is the histological picture in this corner, pancreatic acinar, islets of Langerhans. Look at this well encapsulated endocrine part of the pancreas, containing alpha cell, beta, and exocrine. These are the exocrine portion of the pancreas. The macroscopic structure of the pancreas is composed of exocrine and endocrine tissues. Because it is a mixed gland, both exocrine and endocrine, you should be very much aware of what do you mean by exocrine and what do you mean by endocrine. Endocrine secretion directly pour their secretion into the blood vessel, whereas the exocrine portion, the secretion is poured first in the well-defined duct system into the hollow lumen or into the cavity. So इन दोनों में difference आपको well known होना चाहिए. 98% tissue of the pancreas is exocrine portion, while rest of the is the endocrine part. Stroma consists of delicate connective tissue, sending septa in the parenchyma, dividing into lobes and lobules. So stroma जो है, it consists of delicate connective tissue coming from the capsule of the pancreas, sending multiple septa and divide into parenchyma into lobes and lobules. The endocrine part is well capsulated. Endocrine part is well capsulated. Cellular groups of cells located in the exocrine part are richly supplied by the blood and nerve plexus. So endocrine part it is also called as islets of Langerhans. It is also called as islets of Langerhans. This endocrine part is well capsulated. It is very much vascular. Why vascular? Because all the secretion has to be poured directly into these blood vessels. So that is why it is very much vascular, and nerve plexus are abundant because of the innervation. They regulate the body metabolism as well according to the body need. Exocrine part also containing well-defined duct system to pour the secretion in the duodenum for digestion. So exocrine part consisting of the pancreatic acini, well-defined duct system, secrete the various important enzymes, and these enzymes they first pour into the lumen of the acini, then into the duct system, ultimately into the duodenum second part with combined duct system with the bile duct. Now this is the hypothetical understandable diagram of the pancreas. Look at the picture. So this is common bile duct draining the bile from the liver, formed by the cystic duct and common hepatic duct. So this is the duodenal cap, head, neck and body and tail, and this is the main pancreatic duct. These are the accessory duct, main pancreatic duct. This will join the common bile duct at the ampulla vater, from where it is poured the secretion into the second part of duodenum. This is the diagrammatic presentation. Look at the picture. This is the pancreatic duct. These are interlobar ducts, and these are acini, and these ducts ultimately intercanalicular ducts. These are the ducts, smaller ducts. These are the pancreatic acini. So these pancreatic acini produce the enzyme, pour the secretion within the lumen, then to the duct system, ultimately into the duodenum. Now this is the encapsulated endocrine part. Look at the picture. So it is well encapsulated, containing numerous blood vessels. The secretions are poured within the cytoplasmic cell and then ultimately secrete directly into the blood vessels. So these various enzymes are produced within the cytoplasm in the cell, ultimately drain into the blood vessel to be circulated in the GIT ultimately, and so it have a metabolic effect in the whole body. What is the parenchyma? The parenchyma consists of exocrine part, and endocrine part. Parenchyma means that is the part which is the secretory part. The secretory part are both exocrine and endocrine. Secretory part consists of secretory unit and the duct system. Secretory units are also called as pancreatic acini. Duct system are consisting of centroacinar cell, intercalary duct, interlobular duct, interlobular duct, intralobular duct, interlobular duct, and lastly the excretory main duct. Now, the secretory unit are the parenchymal pancreatic acini, which are 4 or 5 cell unit having central lumen. Now, we will discuss in the next slide. The endocrine part is the consisting of a well encapsulated. It is also called as islets of Langerhans, beta cell, alpha cell, and then delta cell. 3 types of cells are visible according to their staining property, according to the mode of secretion. Beta cell secrete insulin, alpha cell secrete glucagon, whereas delta cell secrete B cell somatostatin. Now this is the section. These are the septa. This is the islets of Langerhans, pancreatic acini. The ducts are also visible. So this is the cut section. Pancreas, body, tail, and head. Duodenum. This is the entrance of the common bile duct with the pancreatic duct. The secretory unit. So secretory unit are the secretory acini and the zymogen granules. Look at the picture. This is one unit of a secretory acini. The nuclei are toward the basal side. The cytoplasm is full of zymogen granules, that is the precursors of the enzymes, which are a long list of the enzymes which are secreted by the pancreas. So these are the granules or various enzymes which are the proenzymes. When activated within the duct system, then they become active and pour within the duodenum to perform a specific function for digestion. Now multiple cell line the acini, and then you see a very small lumen from where the secretions are get collected. So these are the around is the lobular formation, the connective tissue layer. Now these all are jam-packed with the zymogen granules. The nuclei are toward basal side. Now the cell is protein synthesizing. The pancreatic acini cells are protein synthesizing, and you all know that the protein synthesizing cells are those which having a characteristically, that is the rough endoplasmic reticulum, well-defined Golgi apparatus, and nucleolus is prominent. All the synthetic machinery of protein synthesizing are there. Cytoplasm is secretory vesicles as well as the secretory granules are present. Now this is the acinar cell electron microscopic picture. Quite understandable. Look at the picture. This is the nucleus, well-defined nucleolus. This is the rough endoplasmic reticulum all around. Nucleus is toward basal side. Numerous Golgi complexes present, and these Golgi complexes condense the vesicle which is forming within the endoplasmic reticulum. These are transport vesicle. This is the lumen of a acini. So all the secretion, that is the proenzymes or the enzymes, zymogen granule poured in the lumen, they become active enzymes. So enzymatic production is a protein synthesis. So all the organelle of the acinar cell, they are protein synthesizing. Hence it is staining purplish in color. It is staining purplish in color. That is staining basophilic, not eosinophilic. Although mitochondria are there. This is the mitochondria. So these are condensing vesicle. These are mitochondria are there. But more of the basophilic staining is toward basal side for the endoplasmic reticulum. Golgi from body prominent. The ribosome, the characteristic present. Then this is the nucleolus prominent. Secretions are poured within the lumen. This is this acinar cell by electron microscopic picture. Now these are the pancreatic digestive enzymes present within the gut, secreted by the pancreas. For the digestion of protein, trypsin, chymotrypsin, and carboxypeptidase and elastase. These are the four protein digestion and digesting enzyme: trypsin, chymotrypsin, carboxypeptidase, and elastase. So these are the enzymes which meant for the protein digestion secreted by the pancreas. For digestion of carbohydrate, pancreatic amylase, very important enzyme, which is the key enzyme for the digestion of carbohydrate. Pancreatic amylase, although it is also amylase present in the saliva also, but in the pancreas it is the pancreatic amylase which is the key enzyme for the carbohydrate. For digestion of fat, lipase, cholesterol esterases, phospholipase, colipases, bile salt activated lipases. So all these enzymes, lipases and esterases, meant for the fats absorption. So this is the list of various enzymes secreted by the pancreas for all sorts of the incoming food particle, protein, carbohydrate, and lipids. So it is so important exocrine part of the pancreas. The endocrine part, alpha cell, this beta cell, alpha cell, and D cell. Insulin is secreted by the beta cell, glucagon is secreted by the alpha cell, and somatostatin by D cell. So these are the endocrine portion, islets of Langerhans, which secrete these three important enzymes. What are their function? Increase uptake of glucose into the cell, promote glycogenesis, lower blood sugar level. ये insulin जो है is a very important enzyme which controlling the whole body glucose metabolism. So insulin deficiency produce the insulin dependent diabetes mellitus, whereas insulin, when it is abundant but uptake is not so proper, so it is called as non-insulin dependent diabetes mellitus, usually produced by this lack of enzyme insulin. Raised blood glucose level, excretion is not produced, but stimulus is that when the blood glucose level is increased, insulin is increased more, so insulin is uptake of cell by the increased, promote glycogenesis in the liver, so it is stored in the liver, in the muscle, and various tissues. So insulin is only secreted when there is a raised blood glucose level. Glucagon is an enzyme which promotes glycogenolysis. Glycogen present in the stores of the liver, it is break down into glucose with the help of this enzyme secreted by the alpha cell. It's only stimulate these glucagon by the low blood level. Low blood sugar level, glucose level will increase the excretion of glucagon, which promote what? Glycogenolysis, increased blood sugar level. Now, somatostatin, this is the controlling enzyme which control the glucagon and insulin excretion, prevent the fluctuation of blood glucose, gut motility, and excretion of the various enzymes. These are multifactorial enzyme activity by the somatostatin. It maintains the blood glucose level and necessary nutrients within the GIT. So these are the important enzymes secreted by the islets of Langerhans, present within the pancreas in the parenchyma, insulin, glucagon, and somatostatin. This is the islets of Langerhans picture. Now this is the hypothetical diagram. In the center you see a beta cell which secretes the insulin, amylin. So in the periphery at the rim you see a alpha cell. This is the glucagon. Now see, this is the periphery. Mostly excretion, the cells are glucagon in the center. These are the beta cells which secrete amylin, whereas the D cell are also located at the periphery. So it is the somatostatin. Few F cell pancreatic polypeptide is also present within the periphery of the rim, well capsulated, surrounded by it. This is the islets of Langerhans, alpha cell, beta cell, and D cell, and F cell. This is the blood microscope picture, hematoxylin and eosin staining. So look at the picture. So this is the well-defined encapsulated islets of Langerhans, very vascular stroma, alpha cell, beta cell, and D cell and F cells are present within this. Secretion is insulin, glucagon, polypeptide, and somatostatin. Now, these are the duct system, interlobular duct system. Now, these are the pancreatic acini. It is the containing zymogen granule, nuclei are toward the basal side. The lumen is narrow. All excretion pour into the lumen and through the duct system, ultimately drain into the duodenum. So, staining is basophilic due to the protein synthesizing cell. All the enzymes, most of the important enzymes, all are protein, and they are secreted in the pancreatic acini within the lumen. This one is the electron microscopic picture. Look at that. The nuclei are pushed almost toward the basal side. The apical side, or the whole of cytoplasm, is filled with granules, which are the precursors of various hormones. These hormones are stored within the cell and ultimately pour the secretion within directly into the capillary plexus. So these capillary plexus drain these various hormones and circulate it toward the whole body, from where they produce action at the time of need. So look at the difference. This is a largely deeply stained. This is the lighter stain. So it is the beta cell and the alpha cell. Alpha cell secrete the glucagon, whereas beta cell secrete the insulin. Now this is the duct system of the pancreas. You all already know that the duct system, intercalated ducts. So intercalated ducts are the first ducts arising from the centroacinar cell. What is centroacinar cell? Because some cells of the intercalated ducts, they are within the lumen of the pancreas. ये आपने ज़रूर डिफाइन करना है कि centroacinar cell क्या होते हैं. These are the cells of the duct system, simple cuboidal epithelium. So they are present within the lumen of the pancreatic acini. उनको हम centroacinar cell कहते हैं. From the centroacinar cell, the intercalated duct starts. From intercalated duct, it becomes the intralobular duct. Then interlobular duct drain into interlobular duct, then the main pancreatic duct. Now these are the lobule, and these lobule having multiple acini. Intercalated duct, centroacinar cell, intercalated duct, then interlobular, intralobular. So all these ducts ultimately drain into the main pancreatic duct. So this is the islets of Langerhans. Look at the picture, the vein and artery, they are richly vascular. So this is the islets of Langerhans. All types of 4 cells are present within these islets. Directly drain because these are the hormone, they will directly drain into the blood vessel. This is the anatomical presentation of a pancreas in a duodenum. Repeatedly you have seen that is the major duct, interlobar duct, then is the common bile duct, both join. This is the accessory duct, and then they will enter the ampulla, major duodenal papilla, from where pour the secretion into the duodenum. So there are 2 different mechanisms, duct system as well as the blood vessel system. Blood vessel for endocrine portion and duct system for the exocrine part. This is all about the various gland system which help the digestion of the GIT ingredients which are coming from the oral cavity up to the duodenum, then small intestines. All these glands are very much helpful for the digestion of the various foodstuffs, because they have multiple types of enzyme, multiple types of hormone which regulate the activity of GIT. Thank you very much. Now we move on to the next system of the body, inshallah. Thank you very much.